Okie dokie, sorry chokies, let's get started. So, in today's lesson, we're going to be talking about points of intersection, which we've kind of talked about already, but I'm going to show you a couple different kinds of them. So recall that a point of intersection is where two lines meet on a graph, and today I'm going to show you how to find a point of intersection using equations. So, specifically in this lesson, one of the things we're looking at is word problems. It's a really big deal in Chapter 5, and it's continued to be a big deal throughout the rest of this book. So, let's look at this one. We're looking at two different clubs. So, I'm going to underline things. I would recommend doing this on word problems. The science club started out with $20. So I know that they started out with $20. It's very important wording there. And increased its balance by an average of $10 per week. Okay, so those are all very important words there. So let's create an equation based off the science club. Okay, so the science club is y equals. So remember that we have the format y equals mx plus b, correct? Now we've looked at this in tables, in patterns, in graphs. Now let's take a look at it in word problems. Same idea. Let's look for what my growth is. So this first part said they started out with 20. It does not say that they add 20 each time, so they started with 20. This one though says they increased their balance by an average of $10. So increased is our key word here. It means growth. So our growth then is $10. So we'll make 10x plus, and then b, recall, is beginning or starting. And this one literally says started it out with $20. So that's our b. So that is the equation for the science club. Looking at the math club, it said that they saved $5 per week after starting out. Okay, so that's an important money there. After starting out with $50, so starting out with $50 at the beginning of the semester. So they saved $5 per week. This per week is really important because it means that it continues to gain $5, right? So the math club, its growth is going to be 5 because of that per week. And then it says they started out with $50 at the beginning of the semester. So that means our starting out, our B, is 50. Now you're going to see that these rules tend to be a lot bigger than what we're used to seeing. We're going to be using hundreds and 50s and 10s and stuff like that, as you can see here. So I've created my rules. So next thing I'm going to do is I'm going to create a table, because I'd like to show you how to find the point of intersection is in a table. Ms. Schmidt is going to remind you of this in the next couple lessons. But I'd like to show you here. So what I'm going to do is I'm going to create a double wide table. So I'm going to have Science Club up top, Math Club on bottom. You can do this. Actually, you know what? I take it back. We're going to do something different. This happens sometimes, and this is totally okay. We're going to do something a little different. Okay. The whole goal of most of these problems is to figure out when are the two the same. So I have the Science Club and the Math Club, and what I want to know when will the two clubs' balance be the same? That is my goal. So if we're going by week, see it says per week, we'll start with a week 0. So if we look at our two equations, oh, sorry, there we go, should be able to see both of these. Okay, if we start with our two equations, if I was to put 0 in here, I'd do 10 times 0 equals 0, plus 20 is 20, which means that my science club starts out with $20, right? That's literally what they say. My math club says they started out with $50. So right now it would look like the math club has more money, but as we go along, we'll see that that starts to change. Week 1. So we know that my science club is increasing by $10 per week, so we're going to add $10. And we know that my math club is saving $5 per week, so they're increasing by 5. So they're at 55. So week 2, again, we're going to add another $10 to science club. I'm going to write a little plus 10 so I remember. And we're going to add another 5 to math club, so we're end up at 60. Week 3, we're going to add another $10, and then another $5. Week 4, we have 60 and 70. Week 5, we have 70 and 75. I think you know what's happening here. Week 6, we have 80 and 80. I'm going to do one more just to show you what's going to happen. Of 90 and then 85. So as you can see, the science club has overtaken the math club. And the science club now has $90 at the end of the 7th week, and the math club now has $85. So what we're looking for here, the point of intersection, is right here. On the 6th week, they both have $80. Now, this table method won't always work because sometimes it could be week 200. Do you really want to write out 200 weeks? Probably not a great idea. So, I'm going to show you how to do it with a graph. And then at the very end, I'm going to show you how to do it with equations. So hang on tight. Stick around for me. I know this might be a little longer video. If you don't have graph paper, you can very easily do graphs on just normal paper. You just got to be a little bit more precise, and you probably want a ruler around. I'm going to make this have a larger y-axis, because if you noticed, I'm talking about profits. Do profits ever go into the negatives? They do. But if we look at both of my problems here, they're not in the negatives, right? They're gaining. They're not losing money. If you're losing money, then yeah, your profits might be in the negative. It's kind of a trick question there for you guys. Okay. Now, because my numbers here are kind of big, I mean, I have to start at 50. I'm going to count by... Okay, I'm going to count by 5s going up. I'm only going to count by 1s on my x-axis, though. A couple of people have asked me this. Yes, your x-axis and y-axis can be different counting methods. For instance, I'm going to count by 1s on my x-axis, but I'm going to count by 5s on my y-axis. Okay, so I'm going to go up by 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130. Now, you're probably thinking, Miss Nack, you totally could have done that off camera. We didn't need to watch that. Yes, but I do know that there are some of you who are still confused about how to make a graph. So I like to do it on camera. I apologize for it taking extra time. I want to point out here, see my x-axis is all numbered consistently. Each box equals 1. And my y-axis on both sides is numbered consistently. Each box equals 5. The axis needs to stay consistent, but they don't have to both be counting by the same thing, which is really pretty cool. Okay, we're not going to use the table because I want you guys to get used to not using that with equations. We are, though, going to use our equations. So we're going to graph Science Club in blue and Math Club in red. So Science Club, it's going to start at 20. Actually, I'm not going to use blue. This is very thick and it's going to make weird lines. We're going to use purple instead. So Science Club starts at 20. So we're going to go to 20 and we're going to put a dot. Okay, then it increases by 10 each time. So if you recall, we have rise over run. So I did 10, and then every whole number can be put over 1. So basically, if you don't have a fraction for your growth or slope here, then you're going to want to just put a 1 under it. That's basically all we do. So on our graph, we're going to go over 1, which is just 1 block, and then up 10, which is 2 blocks in this case. And we're going to do that. I like to do it for most of my graph. Now you're going to notice that I kind of just drag my marker over here. Once you get good at this, you can make these really fast little L's. If you need to, though, you can always like do some dots. I try not to do too many of them, otherwise it starts to look a little weird. Now, I haven't taught this one to you yet. This is a fun trick. Let's say you've reached the end and you want to backtrack. What do? Well, instead of going over up, you're going to go over down. Over down. Over down. And basically you're just going to do the same process just backwards if you want to get to the other side. So, and now we're going to connect all of our dots. There's a lot of them, but because I did it on a graph, it should all line up. If you're doing this on normal paper, it may not totally line up, and that's okay. But try to get the line to go through all of your dots, if not evenly, but try to get them all. Okay, so purple equals Science Club. Red is Math Club. So Math Club starts at 50, so we're going to go up to 50, we're going to put a dot. That's why we call this the beginning or the start, because it's where we start on a graph. And then mine is increasing by 5. So again, rise over run, you're going to do 5 over 1. So I'm going to go to my graph starting at 50, I'm going to go over 1, up 5. In this case, that's just 1 box and 1 box, because boxes this way count as 1, boxes this way count as 5. So I do 55, 60, 65, 70, 75, 80, 85, 90, 95. I'm just going to do that many because it's going to be a lot of dots. Okay. You should notice that it's literally a dot every single intersection as we go down, or a lattice point. And these are all lattice points as we go. That can make your life a lot easier once you realize that. A couple of you have asked if I like the graphs that have a growth of 1. I do, because they're very nice and easy. Typically. Sometimes they can be annoying. Like on this one where it's very big. Okay. So I have 2 very nice and neat lines here. Ooh, I need more light. There we go. My point of intersection is right here. It's where my 2 lines have intersected. So I will find, if we go down, that is on the 6th week, and it is at 80. Boom, we did it. Look at us, geniuses. And that's my point of intersection on my graph, which is pretty cool. I understand this is like a 14-minute video. It'll probably be like a 20-minute video by the time we're done. But I got one more thing to show you. I just want to show you real fast before we get onto equations that 680 and 680. See, those are all consistent. That's the way that should be. So if you're ever confused in a test, graph it. Make a table. Okay? Okay. Our next thing I really want to briefly talk about, and I'll talk about this again in the end, is called EVM. I won't go through the whole process. I'm just going to show you how to get it started. EVM stands for equals, values, method. It's a very long name. I call it EVM because I am lazy, just like I call point of intersection POIs. What equal values method is essentially telling you is saying that if you look at these 2 equations, they both equal y, right? I don't know why I paused there because I'm not going to put a question for that. They both equal y. Now, here's the question I'm going to put into Nearpod. Does y equal the same thing? The answer you should have put is it could. So that's the great thing about this, is that y could equal the same thing under a specific circumstance. AKA, there is one value of x out there that's going to make y the same. So what you do is you're going to get rid of your y's. 10x plus 20 equals y. And if 5x plus 50 equals y, then 10x plus 20 should equal 5x plus 50. This is math logic for you. They both equal the same variable, therefore they both equal each other, but for only one value of x. Now what you have is your standard equation problem. You know how to do this. You're going to draw the line, you're going to solve, and I think you'll find when you solve and get to the end, you're going to find that x equals 6. Right? We've already found that on the table in the graph. X equals 6. And then if you took 6 and you put it back into here, so we'll do that. Six times 10 is 60, plus 20 equals 80. We can do that on the other one as well. So you can do this as a guess and check. I wouldn't recommend it because sometimes they're not nice. Sometimes they're decimals. 5 times 6 is 30, plus 50 equals 80. I've already known this. I've already tested this on my table and my graph. But if I were to solve this equation, I would come down to x equals 6. Right? Actually, you know what? I'm just going to solve it for you really fast. You guys should know how to do this by now. If you don't know how to do this by now, please ask a question. Okay? I'm going to subtract 20 from both sides. I have 5x equals 30. Not 30. Yeah, 30. I was right. And then we divide both sides by 5. And we end up with a single x equals 6. See? Boom. And just like I proved here, if we plug 6 back in, we should get 80. Those are the same numbers that are consistently showing up in all of our important pieces. And that's it. That is how you solve a word problem using all of the different forms of points of intersection. I will review all of this in the ending video, so if you didn't get it, stay tuned for that one. Have a great day, everybody.